Okay, now we're finishing up our final lesson here. We're going to talk about natural logarithms. Up to this point in the unit, we've learned about the exponential function that has e as a base, the irrational number e. Now what we need to do is we need to take the inverse of that particular exponential function. And so if we do that by switching the x and the y and then taking the log with the same base, we end up with our inverse, which is y equals log base e of x. Now what you really need to understand, and what you've probably seen on your calculator at this point, is that this log base e really means the same thing as ln, the natural logarithm. And so you've probably seen that a little bit in Math Excel. You probably run across it on your calculator and really didn't know what it meant. And so now anytime you have a logarithm that has a base e, in place of that you can use ln. Okay, so now I'm going to just kind of show you an example of how they're similar. So if I do log with a base e, I'm going to get that base e out of this template box, and then I'm just going to use a random number. I'll just use 15 and I get 2.708. Now I'm going to show you how the natural log, the ln, actually creates the same thing, and you can see that those are the same value. And so really now you can see in this concept box that an exponential function with a base e has an inverse log, but instead of log base e we use ln, and you can see the graphical representation of that. Again, 1, which is understood to be in front of the e value, is our y-intercept in the exponential function, and of course the symmetric over the diagonal shows that the x-intercept is 1, 0 for the inverse. So let's take a look at sample problem number 1. We have a problem that asks us to simplify as a single natural logarithm. And so you've learned about log properties back in a previous lesson, so you can use all of the log properties and rules that you've come across in exponentials and logarithms to work with the natural log the same way. So go ahead and try sample problem number 1. Okay, first thing I'm going to do is I'm going to change this power. And I'm going to go ahead and actually take that and change 15 squared to an actual number. So now we need to condense this. Simplify means condense, so we're going to condense it down to a single natural logarithm. And since we have subtraction, that leads us back to division, and of course we can simplify that value, and so we have a single natural logarithm. Alright, I'll stop right there. In the next video we'll look at some sample problems involving natural logarithms and equations.